Welcome, dear students. Today we will discuss about your theorem 10.1 and 10.2. Okay, so you must have learned or you must have gone through 10.1 and it is about tangent. Okay, so what is a tangent? Tangent is a circle where a line segment or a straight line and a circle have only one common point between them. Okay? Okay. So, do you know another thing? Before we prove theorem 10.1, you must know the idea that to a line segment, the distance, the shortest distance from an exterior point is the perpendicular distance. You know, you have to accept it without proof. Okay, so these two things you need to know before proceeding our theorem. Okay. So, what is the theorem? The tangent at any point of a circle. Suppose this is a circle, S1 circle. Tangent at any point. Suppose this is the point where I draw a tangent. This is a tangent having one common point between the circle and suppose tangent T. Okay, is perpendicular to the radius through the point of contact. Okay, so point of contact is this and perpendicular to the radius. Suppose this is the center O and this is the point of contact this. So this will be perpendicular. You have to prove this will be the perpendicular. Tangent at any point, suppose at point P, the tangent is drawn in a circle, is perpendicular to the radius through the point of contact. Perpendicular, this is the radius and point of contact, OP is the radius. So, in the theorem, you need four things. What is data given? What is data given? S1 is a circle. Okay, and O is the center. Okay, and T is a tangent at point P. Okay, this is the data given. What is to prove? To prove, you need to prove the OP is perpendicular to the tangent T. Okay, or T is perpendicular to OP. The same thing. So, construction. The third step is construction. What extra figure you want to draw or extra line you want to draw or you extra point of contact you want to add. So, let another point P in the straight line, another point Q, suppose this side, Q, another point Q other than P in the tangent T. Okay, you can give the tangent T as different naming also, X, Y or MM like this. Okay, now join OQ. Join OQ. Join OQ. Okay. So now proof. Q point is exterior to the circle. We know that one point of contact point of contact is common to circle and tangent. So except P, any point in the line segment T or in the tangent T will be exterior to the circle. Okay. So in triangle OPQ, if Q is the exterior point of the circle and P is the on the circle, then OQ must be greater than OP. Okay, you have to write here. What to write? Except P, any point Q in the tangent T will be an exterior point to the circle S1. So OP will be less than OQ for every point Q. For every point Q in T, in the tangent T. For every point Q, OP is less than OQ. Okay? So OP is the shortest distance from O towards T. Okay? So OP perpendicular T. This is the proof. You have to just write the things what we know earlier, and in this way you can prove this one. Okay, so this is the perpendicular, this is the proof. Now let's, basing on this you can solve many mathematical problems, geometrical problems. We'll discuss in the next video. Let's go to the 10.2. Okay, what is 10.2? Any two tangent, the length of the tangents drawn from an external point to a circle. Suppose this is a circle S1, and the length of the tangent drawn from an external point. Suppose this is an external point P, and the tangents mean two tangents are there drawn, PQ and PR. Suppose this is the two tangents and this is the center O. Okay, so you have to prove that PQ equal to PR. So what is the data given? You have to write data given that S1 is a circle and O is the center. Okay, and PQ and PR are two tangents. Okay, and to prove, what is to prove? PQ equal to PR. Okay, what is construction? What can I do in construction? Join OQ and OR. Okay, and PQ, PO. Okay, join OQ, OR and OP. Okay, we have to join OQ, OR and OP. Why? Because by joining this one, I will get extra here 90 degree, and if we will get two triangles, and if we prove these two triangles as congruent, I can write PQ equal to PR, Cbse. Okay. Okay. So let's do this. Now proof. Proceed to the proof. You know that from 10.1, OQ is perpendicular to PQ. That means OQP is 90 degree. Okay. Similarly, OR is perpendicular to PR 10.1 because this is a tangent and at point R and this is the radius that pass through that point. So 10.1 shows that, prove that or indicates that OR will be perpendicular to PR. Similarly, OQ will be perpendicular to PQ. So between we have to take three conditions to make the two triangles congruent. Which triangle we need to congruent? POR and POQ. These two triangles. Between triangle POQ and triangle POR. What are the three conditions? One is OQP equal to ORP equal to 90 degree, theorem 10.1. Okay. Second, theorem 10.1. Okay. Second one is OQ equal to OR, radius of same circle. Radius of the same circle. S1 circle is the two radius of S1 circle. It will be same. The third one is OP equal to OP, common side. Common side. See, OP is the side of OPQ and OP is a side of OPR also. So these are three conditions: side, side, angle. Okay. So triangle POQ congruent triangle POR, side angle side, Sir's theorem, SAS. Condition SAS. Hence, I can write from these two triangles PQ equal to PR, Cbse. Proved. Corresponding parts of congruent triangles. Okay. So we will discuss mathematical problems regarding this theorem, which will be applied in that numerals. Okay. Thank you.